In this Mathlab activity, we will talk about the 2:1 guy. Who is the 2:1 guy? It is the centroid of a triangle. What is centroid of a triangle? It is the point of concurrence of medians of a triangle. So what is a median first of all? Median is the line joining the vertex to midpoint of opposite side. A triangle has 3 vertices, so it will have 3 medians. And the median's lengths will be same in case of equilateral triangle. In case of isosceles triangle, 2 medians lengths will be same. But the medians of whatever be the kind of triangle, they are concurrent. Concurrent means whatever be the type of triangle, if you draw all the medians, they will pass through one point, that is called centroid. And the centroid is the 2:1 ratio guy. So now let's see how to get centroid. For that, this is a right triangle. So we have this, connect these two ends. When we connect, and just prepare a small crease here, just press it. In that way, we get the midpoint. This midpoint we have to connect to the opposite vertex and we get the median. So this is one of the median of the right triangle. Similarly, connecting these two endpoints, we get the midpoint of the hypotenuse. Midpoint of hypotenuse, when we press it or crease it, connecting to the opposite vertex, we get the second median. Similarly, these 2 points, when we connect, we get the midpoint, and this midpoint is connected to its opposite vertex, and when we crease it, we get the third median. So for this right triangle, we have, triangle has 3 sides, 3 vertices. So there are 3 medians. And all the 3 medians are concurrent. It's not like 2 medians intersected and the third median passed beside it. It's not like that. For a right triangle, all the medians are concurrent. And this median we denote by the letter G. Median of a triangle divides the median in 2:1 ratio. In this case, this is 2, this is 1 ratio. And in this case, this is 2 and this is 1. The centroid is the point of concurrence of medians and it lies within the triangle. Next, about the obtuse triangle. First, we will create the medians, which I already created, by holding these 2 points, one above the other, and just pressing, we get the midpoint of this side. And this midpoint, when held between, when pressed to the opposite vertex, we get the one of the median. So this is the median. Similarly, this end, when held like this, we get the midpoint, and this midpoint, by pressing, we connect to its opposite vertex, we get the second median. And this centroid is the 2:1 guy, means centroid divides median in a 2:1 ratio. We can verify that also. Like, I have a measuring scale here. So the total length, I'm just measuring it from 0 up to, this is up to 60. And where is centroid? Centroid is at 40. So 0 to 40 and 40 to 60 is 20. So 40 divided by 20, it is 2:1, 4 by 2, so 2:1. So centroid divides median in 40. In this case, 40 is to 20. 40 to 60 is 20, no? So 2:1 ratio. Is it true for all other cases? Let's see. So I kept the 0 at this point and the vertex is coming around 55. Where is the centroid? Centroid is somewhere. Okay, we are measuring from this side. So this is somewhere close to 20 G, and this is somewhere close to 55. Okay, so this is approximately 20 and this is approximately 20, 10, 20, 30, something like that. So 35 to close to 20. 35 and close to 20 is also approximately 2:1 ratio. Is it true for the third median? Let's see. At the vertex, I kept 0 and the median there, it is some 5 division next to 20. So this also is coming in 2:1 ratio. So median is divided in 2:1 ratio by centroid. So this is 2, this is 1, this one is 2, and this is 1. In case of obtuse triangle also, the medians are concurrent. Point of concurrence is called centroid. Centroid lies inside the triangle. Now this is the case of acute triangle. So we have seen right triangle, obtuse triangle, now acute triangle. Acute triangle, similarly, how to get the midpoints. This midpoint, just connecting, hold these two vertices together, one above the other, like this, and just press a bit, and then we get the midpoint. Whenever we do lab activities, we should not use measuring devices or geometry box devices, just crease and get. So this is a midpoint. Midpoint connected to opposite vertex, we get the median. So median is a line joining midpoint to opposite vertex. Similarly, its midpoint is this and its midpoint is this, and we get 3 medians. And all the medians lie inside the triangle point of concurrence. 2 lines intersect. More than 2 lines, when they meet at a point, we call that point as point of concurrence. So point of concurrence of medians is called centroid, and centroid divides median in 2:1 ratio. Let's have that verification too. So this is the measuring scale that I'm putting between vertex to the midpoint, and you see, okay. Yeah, so 0 up to some division, few division next to 25, and from there up to few division before 40. Okay, this is 25 approximately, say, and this one is few division next to 10, approximately midpoint of 10 and 15 here. So here 2.5 division, and here it is 1, 2, 3, 4, 5 units, and here 2.5 units. 5 units, 2.5 units is 50 by 25. 50 by 25 is 2 by 1. So median divides the centroid, divides the median in 2:1 ratio. In this case also verified. So centroid is the point of concurrence of medians, and the centroid guy, this one, divides the median in 2:1 ratio. When you do this activity, do it purely by paper folding, creasing to get this, fix it in the lab record, and write every property related to centroid of a triangle, starting with the definition and its properties.